Alright, and here with an empty project, and we are going to implement the main function. And then I'm going to implement my rendering engine. And let's do the the standard stuff here. Alright. Let's do the test run, see if everything runs properly. No link errors. Nice. Okay, then I'm going to implement the framework functions. The usual stuff. The onload function. The update frame. And the rendering one. And the unload one, I personally never use that one, but why not? Let's do it. Okay. And we will need the physics class. Right now, I will make it in a single file. I'm thinking to have the things to make things simpler. Right? So let's have the physics class here. Let's call it simple physics because it is a very descriptive name. It will be simple physics. That's it. Okay. And we will need, what else? We need the idea of the node. Like, let's call it particle. Let's call it class symbol particle. The particles will be these nodes. Actually, all the physics engine will simulate is just these particles and how they react to each other. Not sure if we will make any particle to particle collision. I'm not sure if that is necessary. Although in the actual game it is like bridges and stuff which you can ride on them. Anyway, we will see when we will get there. So yeah, definitely we're going to have these guys are protected from this. Are protected overloaded functions. Overridden functions actually, as we'll see. And then we will need to have the physics, the simple physics. And like so. Now this guy definitely needs a vector of simple particle called, guess what? Particles, yeah. Okay. And then its particle, for now, for the beginning, it will have a vec3 for the position, I'm going to initialize it like 0. Okay. We will need to have an F32 float number mass. Let's initialize it with 1. We will need epoch3 for the linear velocity. Simple stuff. And linear acceleration. Okay. And epoch3 0. Also, I have to start a timer. I forgot about it. Yeah, that is nice. I will make this as a struct, okay? Or no, let's make it class. It's okay. Let's make all these members public because why not? And then we need no, I will not make it now. I will make this case later. Definitely we are going to need, come on, help me, void apply force here, right? Const3 reference force, so we can apply force to each particle. And const 3 reference by position. So we are able to apply a force to each particle at specific position. And the reason for that is to be able to calculate linear velocity and also angular velocity or momentum or angular momentum for each particle if we decide to do it. For now I will just initialize this with a default value of epoch3 0. So yeah. Okay, now the functions for the physics. Let's make public this guy. I know I can just make this as a struct, but I don't know. And then here we have to do the usual update function here. So all the physics will get updated. So update frame. It's the naming convention I'm using. Const frame time. Our delta. And then we need to have some private functions here. Void update kinematics. Process. Actually, update static collisions. Update dynamic. Is that collisions or response actually? Anyway, it is the same. Dynamic collisions. Not sure if we need the delta time there, but void update constraints. Yeah, there it is. So I believe, oh yeah, also we need to have another class here called simple, come on, please, simple constraint and probably we need to have the UI52 as an index to two simple particles. Yeah, I am going to call them A and B. Like so. Usually I am naming these guys like left and right, but I don't know. Let's make it like this, yeah, left and right. Yeah. We will return to this thing here later on. Let's just have a vector of simple constraints, and there it is. Okay, now in this let's see if we can compile. I don't see the reason why we cannot compile, but let's see. Okay. So let's go ahead and render these guys. I will make, oh yeah, we also need for each simple particle, besides the mass, a radius, right? Let's put 2 radius. Let's select this. Okay. Also, you need to be there. And on the render frame, I'm going to just draw simple circles on screen. I have a helper function that can draw shapes, and I need to clear that one. Oh yeah, I also need a camera, right? Alright. And then we are going to draw this thing. And for each simple particle, const simple particle reference, what? Particle in physics particles. Come on. To circle with radius of particle radius. Let's say 12 segments. with the color of white, like this, and then another one with a blue, and the radius will be minus 0.1 or maybe 0.2. Oh, no, 0.1 will be fine. I hope, I believe. And the location, set matrix, push matrix actually, translate, make for, I'm using GLM for the math as a math library. Particle position. Then we need to put the matrix there. Okay. Now for the beginning, I need to specify the camera dimensions actually. Now the width is going to be, let me think about it, because we will go for orthographic projection. And the width, let's implement the onResize function here. Resized. The width will be whatever the width of the window is, which is UI16. It's an unsigned short. I will make it as a float, and then I'm going to divide actually, yeah, let's say camera pixels per meter. Yeah, or it is meters per pixel. No, it's pixels per meter. Okay, so let's define that thing. Fine. Let's go ahead with 10 for now, and the same for the height. Yeah, this is Visual Studio. Okay. Then of course we need to update the GL viewports. So we are drawing to the entire screen of the window. We can hide. And we're checking for any errors during that process. And oh my god, color buffer bits. We are clearing the screen. Come on, we're clearing the screen. and then we're drawing, right? I will not enable the depth function yet. Yeah, that should be okay. So let's build. And run. And yeah, nothing. You you know, you just write in code, you execute, and the result is always the same. And this is because we didn't add any particle. Let's go ahead and add a particle to the physics. Let's push back a simple particle with a mass of 1, the radius of 1, and the position. You know what? Let's just do this. Why not? Okay, and now it is time for debugging, right? Oh yeah. We do need to specify a few more things for the camera. Now the world axis is going to be the y-axis for the up and down. It's vec3 actually. The position will be 0 for now, and the camera, no, this is the target. Okay, and the position is going to be whatever the target is plus a unit z or minus, we will see. So we placing the camera to look at the center of the world. The up of the world is the y-axis, and the position is towards us plus on the z-axis. That should work now. Of course, it will not work. See, I told you. Because we also need to specify the depth. Let's go like this. Can you please work? Pretty please. So, oh hi. Oh, look at that. I like it, but it's not what I want. Why that happened? Ah, yeah. Okay. And yeah, there it is. About 18 minutes in, and all we have is a screen, a black screen with a blue dot in the middle. Cool stuff. Okay. So now we can add particles there, and let's what's the next step actually? The next step, I believe, is to update the kinematics. Maybe? Yeah, let's do that. Let's start working on this thing. Let's implement the first function, the onUpdate frame. Not sure why I don't just copy paste everything. And this guy will just call those guys, I should say. You, and then we need to implement that guy. Simple physics. And yeah, here is where we calculate the kinematics, the motion, the physical motion of the object. And the easiest hacky thing we can do is, you know, the usual procedure, right? So we go ahead and let's say for simple particle difference, particles, linear velocity plus the acceleration times delta. And the position is going to increment by the linear velocity times delta. And then the acceleration is going to be 0. Right? Yeah. Not sure why these dots appearing. I do not want to do what. Yeah. So we do have this thing, and now we can just implement the gravity directly here. Shall we do that? Yeah, why not? Let's define world gravity vector. It is vec3 units times minus times 9.8, like this. And then here we resetting the acceleration for the gravitational acceleration, for Earth's gravity acceleration vector or something like that. I'm sorry about my English, but I try my best. Okay. So now we need to update physics. Not shouting. Update frame delta. Now we must have a particle that falls right to the ground. Let's see. Yay! Okay, nice. So now at this time I'm going to have a break, and I will see you in a few moments.